Last week we did graphing parabolas that had the a value of 1. We began by graphing the parent graph. The parent graph is y equals x squared, right? And we graphed it using an input-output table, an xy table. And from that table came these amazing magical coordinates, 1, 1, 2, 4, 3, 9. And we started using this as a pattern because we recognized that the a value of 1, the number that's in front of the x, if that number is 1, if there's no number, if the a value is 1, then the parabola will always be this exact width. It won't be wider, it won't be narrower. The a value does affect how wide or how narrow a parabola becomes. So we learned that we first identify the hk, the vertex, think opposite on h, take k for what it is, and then from that vertex, wherever it may be, you could use a pattern 1, 1, 2, 4, 3, 9. Of course, these will no longer be coordinates, but it is a pattern. And that's what we did last week. For example, this guy right here, you guys don't have, these are notes from last week. You could pull it out if you want. If not, just follow along right here. Step 1 was to find the vertex. You think opposite of what you see there. So the vertex is -2, comma, and you take that number k for what it is. So -2, 4 is a vertex. So if you go to -2 on the x, 4 on the y, you end up right here at that red dot. And from that point, yes, you can make an input-output table to find other coordinates, but the easier thing to do is to first draw your axis of symmetry that runs right through it. And the axis of symmetry equation is always going to be x equals the h value, which is the x value of your vertex. So once you draw this dotted line, then you're ready to get some coordinates. And we did use last week the pattern 1, 1, 2, 4, 3, 9 that we got from that parent graph. Now we know that the a value is -1, which is why we could use a pattern 1, 1, 2, 4, 3, 9. But obviously we're going to use it in a opening down as opposed to opening up. So it's 1 over 1 down, and you get that red dot right there. And then you go back to the vertex 2 over 4 down, and you get that red dot right there. Then you go back to the vertex 3 over 9 down, and you'd end up right there on the edge. And then we map them over to the other side of the axis of symmetry. So 1 unit away, 1 unit this way would be right there. And then over here, 2 units away, 2 units away would be right there. And lastly, 3 units away, 3 units away would be right there. And that's how we graph parabolas. That's what we did last week. That's what we took a quiz on. And that's what you guys already know, right? Okay. Today, we're going to graph parabolas that have a different a value. Okay. Whoops. So we're going to graph this one right here. And I do have some steps up here, but let's not look at this. As a matter of fact, I'm just going to put a line through these 3 steps because we're not going to be using these steps. It is a possible way of graphing, but we're going to go with the way we've been going. We're going to first identify the vertex. So somebody give me the vertex right here. -4, -6. All right, that's great. Let's graph that vertex. Now, this is not a 5 by 5 graph, so I need to be more careful. Counting 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 up here. Oh, I need to be more careful. Yeah, -6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Thank you so much. And what was the second thing we did last week? Axis of symmetry, right? Okay, and what was the equation of the axis of symmetry? It's always going to be x equals h, which in this case is -4. So let's draw that vertical dotted line. I always draw it in green. That'll provide a reflection. Now we're ready for some coordinates. And last week we would use the pattern 1, 1, 2, 4, 3, 9, which came from the parent graph, which had the a value of 1. Does this have the a value of 1? No, it has an a value of 2. So we cannot use this pattern as is because that'll give us the original width of a regular parabola with the 1, 1, 2, 4, 3, 9. We need to modify this pattern. Okay, so modifying the pattern, it's really easy to do. All you have to do is get your new a value, which in this case is 2, and multiply the outputs of your pattern, right? The 1, 1 2, 4, 3, 9. The outputs are the 1, the 4, and the 9. We need to multiply the 1, the 4, and the 9 by this new a value of 2. So I'm going to put a times 2 right next to the 1, times 2 right next to the 4, times 2 right next to the 9, giving us 1 times 2 is 2, 4 times 2 is 8, 9 times 2 is 18. And ladies and gentlemen, we now have our new pattern ready to rock. We have 1 to the side, 2 up. 2 to the side from the vertex, 8 up. Go back to the vertex, 3 to the side, 18 up. This is now our new modified pattern with the a value of 2. Okay? So let's actually go back to the vertex and go 1 to the side, 2 up. Remember, it used to be 1, 1. Now it's 1, 2 because we modified it by 2. And then you go back to the vertex. Instead of 2, 4, it's going to be 2, 8. So 2 to the side, 1, 2, 3, 4, 5, 6, 7, 8. If we go back to the vertex and try 3, 18, 18 is way off this graph, right? It's not even a 10 by 10 graph, so this is way off the graph. So I don't have to bother graphing that third coordinate, but I will map them over to the other side, right there, and we are done. So the only different thing that we're doing this week compared to last week is we're still using the pattern 1, 1, 2, 4, 3, 9. Whoops, that came out crooked. But we're modifying the outputs of that pattern according to our new a value, okay? That's what I was explaining down here. The original pattern is 1, 1, 2, 4, 3, 9. Now let's say that you have a new a value is 2. So you got to modify the outputs of your pattern by 2. So that would mean that you multiply your outputs only, this times 2, this times 2, this times 2. Then it would give you your new modified pattern of 1, 2, 2, 8, 3, 18. Okay? That's what I'm explaining right there. And again, what if your a value was not 2? What if it was 3? Then you would say times 3, times 3, times 3. What if it were 4? You'd multiply by 4, multiply by 4, multiply by 4. So you still have to have your pattern memorized, the 1, 1, 2, 4, 3, 9. But we end up modifying the outputs by whatever your new a value is. Let's say your new a value is 1/2, yeah? So you'd be multiplying everything by half. So you would end up with 1, 1/2. You'd end up with 2, 2. Why? Because 4 times half is 2. 3, 4.5, because 9 times half is 4.5. So whatever your new a value is, you have to modify the outputs by whatever that new a value is. If you got that down, you'll be able to graph any parabola. And honestly, guys, you guys are doing this, you're able to graph parabolas without a graphing calculator. That's really good. In the future, we will be using graphing apps like Desmos, but right now we're gonna work on this stuff manually, which is awesome. So let's take a look at this guy, and let's start graphing. What's the vertex? Negative 1, 1. Okay, negative 1, 1. It's right there. What's the next thing I should do? Axis of symmetry. What is the equation of that green dotted vertical line? X equals negative 1. Okay. Now let's go for some coordinates by using the pattern 1, 1, 2, 4, 3, 9. However, we have this new a value out here of 1/4. So I need to, let me zoom in here. I need to take these outputs. These are the inputs, these are the outputs, and I need to multiply them by 1/4. So this times 1/4, this times 1/4, this times 1/4. So when I go 1 times 1/4, that gives me 1/4. When I go 4 times 1/4, that'll give me 4/4, which is really just the nice number 1. Now when I go 9 times 1/4, and of course you guys could use calculators, right? 9 times 1/4 gives you 2.25. Okay. So what does that mean? It's a little bit more than 2. So let's use these this new modified pattern. I want to highlight the input and the output. We have the input 1, so it's 1/4 instead of 1, 1. Instead of 2, 4, it's 2, 1. Instead of 3, 9, it's 3, 2.25. So let's go to the vertex. The a value is positive. That means it's opening up. So I will go 1 to the side, and 1/4 of the way up. 1/4 of the way up is half of a half, right? If you get a chocolate bar and break it up into 4 equal pieces, you'd break it in half, and then you take those 2 halves and break them in half, right? So half of the half is 1/4. So when I go 1 to the side and 1/4 of the way up, it's not even halfway, it's right there. It's half of the halfway up. So let's put a dot right there. And then the next one, 2, 1, that one's easy. 2 over, 1 up. And then the next one, 3, 2.25. So again, back from the vertex, 1, 2, 3. Let's go to 2.25 up. 1 up, 2 up. Now 2.25, it's just a little bit more than 2, right? It's not even halfway. It's half of the half. So it's right there where my red dot's at. Let me draw it. Right there. And of course, we're going to map these guys over to the other side. See, right here, it's really close. It's 1 unit away, 1 unit away, but it's going to be really close, not exactly on it, but just slightly above it. So right here. Maybe that was a little too low. There you go. And then the other one, it's 2 units away, so 2 units away would be right here. And the last one, it's slightly above the Y level of 3, right? 3.25, but we're going to go 1 unit, 2 units, 3 units, 1 unit, 2 units, 3 units. And there's our parabola. Now, ladies and gentlemen, this parabola is the widest parabola that we've ever drawn so far. And I think right now is a good time to talk about what makes this parabola wide. The A value being what? 1/4. Okay. As a matter of fact, let me do this for you. I know we've done this in the past, but here goes. Record me. Okay. So the A value of 1, right? The parent graph, y equals 1x squared. That's a regular U-shaped curve. Has a pattern 1, 1, 2, 4, 3, 9, right? Regular U-shaped curve with the A value of 1. Now, if I take the A value and make it 2, like y equals 2x squared, that's going to cause it to get narrower. Y equals 3x squared, narrower. 4x squared, narrower. You guys understand what I'm saying? So here's a regular y equals 1x squared. If the A value gets smaller, like let's say you make it y equals 1/2 x squared, that causes it to get wider. Okay, y equals 1/4 x squared, wider. 1/10 x squared, man, that thing's really wide, right? Because it's getting closer and closer to 0. What if the A value actually became 0? It would be a straight line. It wouldn't be a parabola anymore, right? Now, I want to throw out some vocabulary at you guys. When the A value is greater than 1, as it gets greater and greater and greater and greater, it's causing a vertical stretch. A vertical means up and down stretch. So think about my regular A value of 1. My hands, if they're getting vertically stretched, that parabola is going to get narrower. If the A value gets closer to 0, like here's your regular A value of 1, and if you make it a 1/2, it gets wider. We call that a vertical compression. Okay, so we need to get comfortable with the words vertical stretch, which makes it narrower, vertical compression, which makes it wider. Okay, that's actually tomorrow's lesson, not today, but I just want to give you a little taste. Okay, thank you. So it's pretty obvious that the A value of 1/4, that's closer to 0, that's why it got wider. Okay. The closer that the A value gets to 0, the wider that the parabola is going to be. As it increases, it gets vertically stretched, which makes it narrower. Anyway, the domain, like always, x equals all real numbers. The range, like always, y is, in this case, the parabola is above, greater than or equal to that minimum value, which is a vertex y value of 1. Okie doke. So, help me. What's my first step in graphing this parabola? And what is a vertex? -3 and 6. So let's go to -3 on the x. 1, 2, 3, 4, 5, 6 on the y. There it is. What's my second step? Axis symmetry. There it is. And could somebody give me the equation of that green dotted vertical line? X equals the h value of the -3. The x value of the vertex, perfect. And last but not least, we could now get some more coordinates using the pattern 1, 1, 2, 4, 3, 9, but we can't use that pattern until we modify it. How are we going to modify it? multiply it by -2. Now, you could multiply it by -2, or you could just say multiply it by 2, and just remember that because it's negative, it's going to be opening down instead of up. It's totally up to you. If you want to include the -2, that's totally fine. Or if you just want to multiply the outputs by 2, that's totally fine, as long as when you're using the pattern, you're going down, not up. So since you guys said multiply by -2, I'm going to keep that. I'm going to multiply by -2. And I will get 1 times -2 is -2. 4 times -2 is -8. 9 times -2 is -18. So my new pattern is 1, -2, 2, -8, 3, -18. So once again, if I wanted to, I didn't have to multiply all of them by -2. I could have multiplied everything by 2, and I'd have 1, 2, 2, 8, 3, 18. But just remember that you're going down, not up. If you did include the negative, that's fine. -2 means 2 down. So whatever you prefer. Anyways, from the vertex, we're going to go 1 to the right and 2 down, and put a dot right there. And we're going to go back to the vertex, 2 to the right, 1, 2, 8 down, 1, 2, 3, 4, 5, 6, 7, 8. And if you do go back to the vertex and try 3, -18, that's going to be 1, 2, 3. -18 is way off this graph. I'm not going to bother graphing it. Okay? Map them over to the other side, right here and right there, and we are good. Now, you know what, guys? When you draw your parabolas, I know that these are just sketches, but one thing you don't want to do is you don't want to like graph it like this and then start making it go back like that, right? That's incorrect, okay? You need to really draw the arrow appropriately. So don't make it curve back in. Don't even make it seem, sorry about that. Don't even make it seem like if it goes straight down, because it never goes straight down. You do want to make it like if it continues that way, slightly out. Anyways, there's your graph. What's the domain? X equals all our numbers. What's the range? That's right, the y value of your vertex. And we're good to go. So again, the whole purpose of this lesson today is to recognize that when the a value is 1 or -1, you could use a pattern 1, 1, 2, 4, 3, 9. But when it's not, when you have a different a value, like right here we have the a value of -1/2, you have to modify your pattern. Okay. So once again, step 1, find the vertex. What is a vertex? 0, 4. So let's go to 0, 4. That's up here. Axis of symmetry, right through that vertex. What's the equation of that axis of symmetry? X equals?
0.
Yep, 0. And then we move on to the pattern to get some coordinates. The pattern is, or used to be, 1, 1, 2, 4, 3, 9. But we have this new a value of -1/2. Like I said, you don't have to include the negative if you don't want to. You could just put, like, let's say you're running out of space. Maybe just 1/2 is better. So times 1/2 times 1/2 times 1/2. And what is 1 times half? That is 1/2. What is 4 times half? That is 2. What is 9 times half? What's half of 9? That's $4.50. If you're dividing $9 into 2, that's 4.5. Okay, so I'm going to highlight my new modified pattern. It's 1, 1/2. It's 2, 2. It's 3, 4.5. Okay? So from that vertex, because it's negative, I'm going to be going 1 over halfway down, right? So 1 over halfway, and I'm talking perfectly halfway, right? So let's put a dot right there and go back to the vertex, and then now you're going to go 2 over 2 down. So 2 over 2 down, put a dot right there. Why did it come out black? Sorry. And then go back to the vertex, and then 3 over 4.5 down. 1, 2, 3, 1, 2, 3, 4.5, halfway down. So that'd be right there, halfway down. Let's put that dot right there halfway. And we're going to now map these red dots over the axis of symmetry, and I will do them in blue. You'll end up with 1 unit away from the axis symmetry right there at the halfway point, 2 units away from the axis symmetry right there at the y value of 2, and 3 units away from the axis symmetry right there at that halfway point. So there's our parabola. It's definitely wider because it got vertically compressed by that a value of 1/2. Well, technically a value of -1/2. Now, I do want to also give you a little taste of another piece of tomorrow's lesson. Let's go back up to this one. So on this one, there's going to be a section on tomorrow's section that it says, what are the transformations from the original parent graph to this new graph? Now remember, the original parent graph, I want to do it with the highlighter. It had the vertex 0, 0, the coordinate 1, 1, 2, 4, and 3, 9, which is off the graph. So my original parent graph would be something like this. The y equals x squared, okay? Now the question is, on tomorrow's second section, is what are the transformations that the original parent graph goes to get to this new one, okay? So let me explain. Okay, so if we look at the original parent graph, it had the origin 0, 0. And if you look at the very first thing that you see, it's a negative sign. That negative sign on the A, it's called a reflection over the x-axis. Okay, that's why it opens down. So the first transformation is a reflection over the x-axis. And then, because the A value is 2, it got vertically stretched by 2. It got narrower. And then you look at your HK, which means that it shifts 3 to the left and 6 up. So again, the whole transformations from the beginning to this new graph is the negative sign means it gets reflected over the x-axis. The number 2 causes a vertical stretch, and we say by a factor of 2. And then it gets shifted 3 to the left and 6 up, right? And that's how we get from the original to this new one. But that's tomorrow's lesson. Again, I just wanted to give you a little taste of it. Thank you. So the assignment for today is to practice graphing these guys. How about you guys try number 3 right now? Work on it with a partner, and then I'll explain it. I want to pause it. So most of you already finished it. So we're going to begin with the vertex. The vertex is the coordinate opposite of -1. That's +1. Take -5 for what it is. So the vertex is +1, -5. That's way down here. The second thing to do is to draw your axis of symmetry. And yeah, you could give the equation of that vertical line, which is x equals 1. And now we want some coordinates using the pattern 1, 1, 2, 4, 3, 9. However, we're going to modify it by this new a value of 2. So the output 1, multiply it by 2, and the output 4, multiply it by 2, the output 9, multiply it by 2, giving you your new outputs. So that's 2, that's 8, that is 18. So your new modified pattern is 1, 2, 2, 8, 3, 18. I know not all of us have highlighters, maybe you want to circle it, but that's your pattern from the vertex. Because the a value is positive, it will be opening up. So from the vertex, let's go 1 over 2 up. Put a dot right there. Go back to the vertex, 2 over 8 up. So that's 5, 6, 7, 8. And of course, if you went back to the vertex and went 3 over 18 up, you're way off the graph. So it's pointless. Let's not do that last part of the pattern. Map these 2 red dots over to the other side, right there. And right there, whoops, nope, that's the wrong one. Sorry about that. Why did I highlight it? I was trying to erase it. And it doesn't erase. I need to white out here. My bad. So here's my parabola. Wow, that's ugly. Sorry. There it is. Anybody want to see number 4? Yes, I want to see number 4. You want me to explain it? Yes, please. Okay, I'll explain it. You're the best, Mr. Salgado. Oh, thank you. You're too kind. All right, so number 1, vertex. What is it? 0, -3. Thank you so much. Number 2, which I normally do in green. Axis symmetry, x equals 0. That's the only way to get a vertical line right through that vertex of 0, -3. First of all, there's vertex 0, -3. X equals 0 produces a vertical line right through that vertex. Now we need some coordinates according to this new, or modified by this new a value of 1/4. Technically the a value is -1/4. So I'm going to write 1, 1, 2, 4, 3, 9, and I'm going to multiply the outputs of our original pattern by, you could do -1/4, or you could just do 1/4 and just remember that you're opening down instead of up. I'm just going to put a 1/4 to save a little bit of space right here. And I'm just going to remember to open down instead of up. Now that's kind of weird because you have a dot down here opening down. I know a lot of us are thinking, well, it's not even going to fit, but it actually does. Let's work it out. So 1 times 1/4 is 1/4. 4 times 1/4, if you use a calculator, that'll be the nice, beautiful number 1. 9 times 1/4 with the calculator is 2.25. Okay, so here is our new modified pattern. 1, 1/4, 2, 1, 3, 2.25. And we are opening down because the a value is negative. So 1, 1/4 down. So check this out. 1 over 1/4 of the way down, again, is half of the half. So it's right there, just slightly down. Right here. And then we go 2, 1. So back to the vertex. 2 over 1 down, right there. And now here's the slightly unfortunate part, because if I go 3 over 2.25 down from the vertex, check it out. 1, 2, 3. 1, 2, 2.25, man, that's just slightly off the graph. And I want to graph it because it's so close. It's so close. It's right here. Slightly off the graph. Let's now map them over to the other side. Right there. This is a nice coordinate. This one's slightly off the graph. It's only 2.25 below. I mean, 0.25 below. I'm sorry. And there's my parabola. It's definitely wide. Why is it wide? Because the a value is 1/4, -1/4 to be technically correct, which causes a vertical compression. It makes it wider. Do you guys want to try this one? Go for it. I want to pause it. All right, for the sake of time, let's get this going. The vertex is -1. You think opposite of what you see here. You take this value for what it is. There is no value out there, so that's 0. So -1, 0 is right here. The next thing to do would be to write your axis of symmetry equation. X equals -1, the x value of your vertex. That's this green vertical dotted line. Bless you. The next thing to do would be to use your pattern 1, 1, 2, 4, 3, 9, but you got to modify it according to your new a value. So those outputs are going to be multiplied by half. So 1 times half, 4 times half, and 9 times half. So what is 1 times half? Half of 1 is 1/2. What is 4 times half? Half of 4 is 2. What's 9 times half? Half of 9 is 4.5, right? So our new modified pattern is 1, 1/2. 2 to the side, 2 up. 3 to the side, 4.5 up. So if we go with that new pattern, 1 to the side and halfway up, you'd be right there. You go back to the vertex. You go 2 to the side, and half of 4 was 2, which is right here. And you go back to the vertex, and you go 3 to the side, 1, 2, 3, and 4.5. 1, 2, 3, 4.5 is halfway up right there, between 4 and 5. So put a dot right there. Map them all over to the other side of the axis of symmetry. And you'll get that nice, beautiful, perfect parabola. That's definitely wider because it got vertically compressed by that a value of 1/2. So I hope we've done enough examples to know, so you guys know what you're doing. So do numbers 5 and 7 on your own, and it'd be good to practice domain and range. The domain x equals all real numbers, The range in this case would be y is less than or equal to that y value of -3. Right here, the range would be y is greater than or equal to that y value of 0. Now, I did have another worksheet posted on today's post, but I know that this may be a little too much, so I'll give you more time tomorrow to work on that next worksheet. But I want to show it to you real quick. And on this worksheet, I give you parabolas, and you want to, it's like going backwards. You have the equation, or you have the graph, and you want the equation. Now, how could you do this? Well, you first have to identify whether your A is positive or negative. Obviously, the A is positive because it's opening up. And secondly, what is your pattern from the vertex? If you went 1, 1, 2, 4, 3, 9, then it would be the A value of 1. But as you can see, this is not 1, 1. What does it look like? 1 what? 1/2, right? So if your A value is 1 and then up half, and then back to the vertex 2, instead of 2, 4, it's 2, 2, which is half of 4, then you for sure know that the A value is 1/2. And of course, you could identify your H, which is -2, and your K, which is 0, because the vertex is -2, 0, right? So you could all plug it in, or just with this information, we could actually write it out. Instead of plugging in, let's actually write it out. Y equals 1/2, open some parentheses, X, think opposite on H, so that would be a +2, close parentheses squared, and then plus K, plus the K value of 0, unnecessary, you don't need that plus 0. So there's your equation for that parabola, okay? So I will give you this worksheet right now, but don't worry. Right now, let's focus in on first graphing. And I'm giving you this worksheet in case you want to start it tonight. Even though it was assigned tonight, I'm going to give you time tomorrow to work on this and to answer questions. In addition to stating the vertex form equation, I also want the axis of symmetry, which is pretty easy. Second thing I'm going to do is axis of symmetry. That's X equals -2. Just think opposite of what you see here, or just take the vertex X value, which is -2. What else does it ask for? The third thing they ask for is the y-intercept. Where does this cross the y-axis? The y-intercept in this case is 2. It's just where does your parabola cross the y-axis? It's at 2. And the last thing they ask for is the range, I believe. So this is the third thing, and the fourth thing is a range. Y is greater than or equal to 0. So they're asking for 4 things: the equation, the axis symmetry equation, the y-intercept, and the range. So I'll make a separate video on this entire worksheet tomorrow. Right now, let's focus in on those graphing questions. And if you have some time left over, then you could start this. And of course, you could check all of your solutions on Google Classroom. You just have to scroll down to get to the answers.